Welcome, fellow math students. This is Mr. Trutna. That was my hand. Just wanted to make sure it was working. Clovis High School, we're going to go over Unit 6, Worksheet 1, numbers 13 through 20. This is Math 2, as is the kind of the policy or the thing that we do every day. Joke of the day. What did one traffic light say to another traffic light? Don't look. I'm changing. Get it? Explain it to your partner if you don't get it. Alright, after watching this video, remember, crush the like button. Give me some money. Okay, here we go. So this is what Worksheet 1 looks like in Unit 6. Unit 6, Worksheet 1. It is pink. And we've already done the first 7 problems, so we're now on the back side. And we're going to do numbers 13 through 20 actually. Okay, so let me zoom it in here so you could more easily see it if you're following along at home. So notice in these problems, numbers 13 through 19, you're always going to be given two shapes actually that are similar to one another. Remember that symbol right there, which is called tilde, is translated as is similar to. And what we're going to do is we're going to solve for x, okay? And the way that we're going to do this is we are going to set up proportions, okay? And whenever I write my proportions, so what I'm going to do is I'm going to take a side from one of the shapes and compare it to a side of another shape. Okay, and so what I'm going to do is when I write my proportions in this particular problem, I am always going to compare the big triangle to the small triangle. So I'm going to take values from the big triangle and put them in the numerator, for instance 54, and then I'm going to take the corresponding value from the small triangle and put it in the denominator. And here's how you do it. So notice 54 right here is R to S. And if we look up here at my similarity statement, the letters R and S are the second and the third letter. So I go over here and the second and the third letter are UV. So that means 54 has to correspond with 36. So that's going to be one of my ratios. And then I'm going to write as many as I can. Sometimes I might be able to write 3 ratios. Sometimes I might only be able to write 2. Sometimes I might be able to write 4 or 5. But I'm going to write as many as I can and then see what happens, okay? So then my next ratio is I'm going to pick another side from my big triangle, which is 24, and I'm highlighting that in yellow. Hopefully, yeah, you can see that. Okay, and if you notice, 24 is letter R to letter Q, which is the first and the second letter. So we go over here to the other side of the statement. The first and the second letter are T and U. So that means 24 has to match up or correspond with x plus 5. Okay, so and then typically I would be able to write a third ratio, but if you notice there's no information on either side of the third sides, here and here, right here and right here. So those are my only 2 ratios. So then to solve for x, what I do is I create a proportion out of these 2 ratios and I cross multiply in order to solve. Okay, so 36 times 24, I'm going to multiply that out right there. And I'm walking away right now because I got to go find a calculator. I don't know if you can hear me or not, but my calculator is all the way on the other side of the room. So I just walked to the back of the classroom and I'm back. So I'm going to go 36 times 24 and whoops, 36, and I'm doing this off screen on my calculator. You can see that that is 864 if you're doing this at home. And then I'm going to put that equal to, and I'm going to cross multiply the other way, and I'm going to go 54 times x plus 5. Now, when you go 54 times x plus 5, do not say it's 54x plus 5. You would be correct in saying 54x, but then you got to go plus, and remember when you multiply this, you have to go 54 times the quantity x plus 5. So 54 times x, that's where the 54x comes from. But you also got to go 54 times 5, and that's 270. Okay, and now we've created an equation here. We've taken our proportion, we now created an equation, and now I use this equation to solve for x. So I'm going to subtract 270 from both sides of the equation. those 270s would cancel out. 864 minus 270 is 594. So my new equation is 594 is equal to 54x. I divide both sides by 54, and 594 divided by 54 gives me my answer, and it turns out that x is equal to 11. Okay, perfect. There's number 13. Moving on to number 14, notice we say triangle ABC. So triangle ABC, so that's this big triangle right here, is similar to triangle ADE, and ADE is right here. So I'm going to do number 14 the same way I did number 11. So the first thing I'm going to do is I'm going to write out my ratios. And I'm going to write out the big triangle's values in the numerator, the small triangle's values in the denominator. Okay, so let's pick a side from the big triangle. How about side BC? Okay, that's from the big triangle, and that's 2x plus 3. Okay, so that's going to go in my numerator for a ratio. And then BC, if you notice, is the second and the third letter. So that means it has to correspond with the second and the third letter, D and E, which is 15. So 2x plus 3 over 15 would be one of my ratios. Okay, another ratio would be, let's pick another side from the big triangle. Now, if you notice, another side from the big triangle would be A all the way out to B, or all the way over to B, and that would be 20 plus 8. So that would be 28. So 28 would be another numerator for a ratio I would write. And then I would put it over, now A to B is 28, that's the first and the second letter. That has to correspond with side A to D. A to D is 20. So I get 28 over 20. And then if I go to the third side here, notice I have no values, so those are my two ratios that I have to use. I put an equal sign in between them because when shapes are similar, their ratios have to be equal. I create a proportion, and now I cross multiply to solve. Okay, so I'm going to go 15 times 28. That is called the extremes when you multiply these, so that is 420. Then I'm going to go 20 times 2x plus 3. And once again, when you go 20 times 2x plus 3, do not say 40x plus 3. It has to be 40x plus 60. You have to take the 20 and you have to multiply it by the quantity 2x plus 3. So in other words, you have to distribute the 20. Okay, make the means equal to the extremes. In other words, you set the two results equal to each other, and now you solve. Subtract 60 from both sides. That would give me, when the 60s cancel out, 360 is equal to 40x. I would divide both sides by 40. Therefore, 9 is equal to x. So there's my answer to number 14. Okay, moving on to number 15. Same idea, different type of looking shape. Notice we are told that triangle MNP, so that triangle there, is similar to triangle QRP. Okay, so the first thing I'm going to do is I'm going to write out all the ratios that I could write out. Now for this one, just because the smaller triangle is on the left, that's the first thing my eye looked at. When I write out my ratios here, I'm going to put the small triangle's values in the numerator. I'm going to put the big triangle's values in the denominator. Okay, and let's get started. So let's pick a side from the small triangle. How about side MP, which is 24? So 24 over, now notice MP is the first and the third letter in my similarity statement. So that means it has to match up with QP, the first and the third letter. So that means 24 has to match up with 28. So 24 over 28 is one of my ratios. Now let's pick another side from the small triangle, which would be x plus 8. And x plus 8 is NP, which is the second and the third letter. So that means it has to match up with RP, which is 3x minus 9. So x plus 8 over 3x minus 9 would be my other ratio. X plus 8 over 3x minus 9. Okay. Now, typically, if I have triangles, I'd be able to write a third ratio. But if you notice, the third sides are completely blank. So I cannot write any more ratios. So what I do is I put these equal to each other. Remember, if shapes are similar, their ratios are equal to each other. It means they're in proportion. And then I solve this proportion. Okay, so I'm going to cross multiply. So I'm going to go 28 times the quantity x plus 8, and we've talked about this in the previous two problems. How to do this, you're going to distribute. So that would give us 28x plus, and then 28 times 8 is 224. That is going to be equal to, and I'm going to cross multiply the other way. In other words, to get the means, that's called the extremes when I multiply this way. When I multiply top left to bottom right, it's called the means, and I'm going to go 24 times 3x minus 9, so you have to distribute 24 times 3x, that is 72x, minus 24 times 9, I'm doing this off screen on a calculator, 216. Okay, the means is equal to the extremes, so there's my equation, and now I use that equation in order to solve my value for x. Alright, so I have 72x's on the right side of the equal sign, it's 28x's on the left side, so first move is to go to the side that has the smaller amount of x's and eliminate them by subtracting 28x's. When you do that, those 20x's will cancel out, you get a new equation, 224 is equal to 44x minus 216. 72 minus 28 is 44. Now we're going to add 216 to both sides of the equation. That's going to make the equation, this would become 440 is equal to 44x. And then the last step to solve for x would be to divide by 44. So 440 divided by 44 is 10. So therefore, number 15, x is equal to 10. Okay, number 16, we start off, read the similarity statement. Triangle BCD, that's this big triangle, is similar to triangle FGE, that's that smaller triangle. Okay, so first thing I do is I set up my ratios. So I'm going to write big triangles values on the numerator, small triangles values on the denominator, and the only reason I'm doing that is because the big triangle I saw first because it's to the left. Okay, so let's pick a side from the big triangle. Side B to C, which is 39. B to C is the first and the second letter. That means it has to correspond with side F to G, which is 4x plus 2. So one of my ratios would be 39 over 4x plus 2. Okay, another side from the big triangle, pick sides that you know, don't pick sides you don't know, would be side B to D, which is 42. B to D, the first and the third letter, has to correspond with side FE, which is 5x, and I think that's a minus 2. So 42 over 5x minus 2 would be my other ratio. Okay, now, once again, typically you would compare that third side to that third side, but since you don't have values for either of them, you're not going to worry about the third ratio. So these are your two ratios. They are equal to each other. The ratios are always equal when shapes are similar, and now I cross multiply to solve out this equation. Okay, so the means would be 39 times the quantity, 5x minus 2. Distribute the 39, don't forget to distribute. That would give me 195x minus 78. Distributing the 39. Then I'm going to cross multiply the other way, which would give me what we call the extremes. So then you would multiply 42 times the quantity, 4x plus 2. So that means you have to distribute the 42 times 4x and the 42 times 2. So that would give me 168x plus 84. And then those two values would be equal to each other. The means equals the extremes. And now we use that to solve. So I would subtract 168x from both sides of the equation. That would cancel out the 168x's, and that would make my new equation 84. And then 195x minus 168x is 27x minus 78. Keep solving. Now we're going to add 78 to both sides of the equation. That would give me 162 is equal to 27x. Those 78s will cancel. Divide both sides by 27. 162 divided by 27 gives me my answer of x is equal to 6. So that would be number 16. X should be 6, okay? All right, number 17. Number 17, notice what we're dealing with now is we have four-sided shapes, trapezoids to be exact, and they're not in the same orientation. So you got to be careful here. So let's look at our similarity statement in number 17. Triangle KLMN, I'm sorry, it says triangle here, that's a typo, whoops. Whoever wrote this, not me, I don't make mistakes. They just started putting the triangle symbol. So KLMN, that small trapezoid, is similar to PQRS, the bigger trapezoid. Okay, and then I'm going to solve for x. So since the shapes are similar, I'm going to write out ratios. Now, when I do this one, I'm going to do the small trapezoid's values in the numerator, the big trapezoid's values in the denominator. The only reason why I'm doing small in the numerator is because small is the first shape I saw. It's on the left. So pick a side from the small shape, LM, which is 4x plus 4. LM is the second and the third letter, so it has to match up with side QR, correspond with side QR, which is 48. So one ratio is 4x plus 4 over 48. I'll write that over here. 4x, well no, I'll write it over here. 4x plus 4 over 48. That's one ratio. Okay, another ratio would be, now let's pick another side that we know of from the small trapezoid, which would be Rn. Okay, Kn, excuse me. Kn is the first and the last letter, so it has to correspond with P and S, the first and the last letter, which is 60. So 7x minus 9 over 60 would be my other ratio. Now, once again, typically you would write, if you have a four-sided shape, you would have two more ratios to write. But I don't have any information for any of the other sides, so these are the only two ratios I can write. Set them equal to each other because ratios are always in proportion when shapes are similar. And now I'm going to use this equation right here by cross-multiplying in order to solve for x. So I'm going to go 60 times 4x plus 4. So when I do that, that's going to give me 60x plus 240. And then I'm going to cross multiply the 48 times the 7x minus 9. And remember, you got to go 48 times 7x, so that would make 336x. And then you also have to go 48 times 9, so it would be minus 48 times 9 is 432. Don't forget to distribute. All right, now I solve. I have 336 x's on the left of the equal sign. I have 60 x's on the right. Those are smaller, so I'm going to eliminate the smaller x values. So I'm going to take away 60 x's from both sides of the equation. Those will cancel out. 336x minus 60x gives me 276x minus 432. That would be equal to positive 240. You don't have to put the plus sign. Now let's add 432 to both sides of the equation to cancel out these 432's. That would give me a new equation of 276x is equal to 672. And now we're going to divide both sides by 276. So 672 divided by 276 gives me, and now on this one, if I did my math right, I think I did my math right, I get 2.43. So here I get x is equal to 2.43 ... There's a bunch of numbers after that. So I'm just going to say x is equal to 2.43. Okay, if you said 2.4, I'm good with that. All right, so moving on to number 18. Same idea, number 18, triangle RST. So that is the big triangle. So when I write my ratios, I'm going to put the big triangle's values on the numerator. Is similar to triangle YSZ, so that's that smaller triangle. So I'm going to put the small triangle's values in the denominator. So let's pick a side from the big triangle. How about this bottom side right here, which is 3x minus 7, which is side RT. RT is the first and the third letter in my statement, my similarity statement. That has to correspond with YZ. Okay, so that means 3x minus 7 over 2x plus 2 is one of my ratios. 3x minus 7 over 2x plus 2. Okay, then another ratio is I'm going to pick another side from the big triangle, which is S all the way to T, which is 40. So I'm going to go 40 over, now notice ST, the second and the third letter, has to correspond with SZ, SZ. Now SZ is this right here, and it doesn't have a value. But if that's 5, and the entire thing is 40, SZ has to be 35. 35 plus 5 is 40. So it would be 40 over 35. Okay, and then typically I would write a third ratio, but once again, there's no information there. So these are my two ratios. Set them equal to each other, and now we're going to cross multiply and solve for the variable x. So we're going to go 2x plus 2 times 40, distribute the 40, so that would be 80x plus 80. Okay, and that's called the extremes, and then we're going to make it equal to the means, and the means would be the 3x minus 7 times the 35 part. And remember, we got to distribute. So 35 times 3 is 105x minus 7 times 35 is equal to 245. So we're going to get 105x minus 245. Subtract 80x's from both sides of the equation in order to eliminate the 80x's. My new equation becomes 80 is equal to 25x minus 245. Add 245 to both sides of the equation. Those 245's will cancel. My new equation becomes 325 is equal to 25x. Divide both sides by 25, and 325 divided by 25 is 13. So x is going to be equal to 13 for number 18. Okay, so there we go. Number 19, 2 more to go. We're rolling right here. We've only been talking for 21 minutes. Number 19. So triangle CDE, that's the bigger triangle, is similar to triangle FGE, the smaller triangle. So once again, when I write out my ratios, I'm going to go big triangle over small triangle. And the reason why I'm doing that is because the big triangle came first. Pick a side from the big triangle, D to E. That's 6x plus 3. D to E is the second and the third letter. It has to correspond with G to E, 17. So one ratio is 6x plus 3 over 17. Another ratio, let's pick another side that we know from the big triangle. That is C to E, which is 8x minus 1. C and E, the first and the third letter, have to correspond with F and E. So that would be 21. So that means my other ratio is 8x minus 1 over 21. And now, typically, once again, I'd write a third ratio, but there's nothing there, so I can't. So these are my two ratios. They have to be equal to each other because the shapes are similar. And I cross multiply and create an equation. Okay, so I'm going to go 17 times 8x minus 1. So 17 times 8x gives me 136x minus 17, because I got to go 17 times 1. I'm going to make that equal to, and I'm going to cross multiply in the other direction. So 21 times 6x plus 3, 21 times 6 is 126x, plus 3 times 21 is 63. So that's my equation. Okay, and now I'm going to solve it. So I'm going to subtract 126x's from both sides, and because I don't have a lot of room, I'm going to add 17 to both sides as well. Okay, so I'm doing two steps at once. That cancels out the 17's and the 126x's. Move it over here. You might be able to see it a little bit better. That creates me a new equation of 10x is equal to 80. Divide both sides by 10. X is equal to 8 in number 19. Okay, last one, number 20. Now, number 20 gave a lot of people a lot of problems, but I'm going to try to simplify it for you. So notice it says, if triangle KLM, so here's KLM, the small triangle of the two, is similar to triangle PQR, with a scale factor of 3 to 5, find the perimeter of triangle PQR. Okay? And so that's what we're trying to find. Now, if you notice, triangle, so we're finding perimeter. That's the key to this problem. And the fact that we have a scale factor of 3 to 5. Okay, so first of all, let's find the perimeter of the small triangle. So remember, to find perimeter, you just add up all the sides. So what is 6 plus 12 plus 15? That's 33. So that means my perimeter of the small triangle, KLM, is going to be 33. Now, so what I'm going to do is I'm going to write ratios, just like I did with all the other problems. Okay, and I'm going to write ratios. I'm always going to put the small triangle's values in the numerator, and I'm going to put the big triangle's values in the denominator. Okay, but here's the problem. 6, I got nothing to compare to. Notice I don't have anything about these sides. So what's the only thing that I have to compare? Now, remember, I'm trying to find the perimeter. So I'm going to call the perimeter x. So I'm going to compare 33, which is the perimeter of the small triangle, to x, which is the perimeter of the big triangle. Okay, so that's one ratio. Now, I have no other ratios to write, but I do, because remember, this tells me it has these shapes. These triangles have a scale factor of 3 to 5. So that means my other ratio would be 3 over 5. Remember, that's a ratio just means a fraction. Scale factor just means a fraction. And how do I know 3 has to be associated with the small triangle? Well, because it's the smaller of the two numbers. So then, to solve for this, I just cross multiply, like I've been doing all this whole worksheet, or the last part of the worksheet. So I'm going to go x times 3. Well, that's 3x. I'm going to go 5 times 33. That's 165. And I'm going to put the means equal to the extremes, and then I'm going to divide by 3. And whatever answer that turns out to be, that's my perimeter of the big shape. And that's all you had to do. 165 divided by 3 is 55. So that tells me the perimeter of the big triangle, PQR, is 55. Okay, see ya.